We all know that NASA astronauts go through a lot of training, both physical and mental, before going into space. That's because living in space is a completely different experience than living here on Earth, and it has some interesting effects on the astronauts' bodies.
Find out more about their heart-pumping adventures next on Real World.
You probably already know that when in orbit, astronauts' bodies stretch, and they lose bone and muscle mass. But those aren't the only physical effects the astronauts have to prepare for. Let's hear about some other kinds of physiological changes from Canadian Space Agency astronaut Bob Thirsk on board the International Space Station.
During spaceflight, our human bodies have to adapt to this new, unusual living and working environment of spaceflight. Weightlessness affects each of our physiological systems, including our sensory motor system. In addition, spaceflight is not easy. It places significant cognitive demands upon the astronaut crew.
Cognitive, or basically the process of thought. Come on out there. If someone has ever told you to turn on your brain, they're talking about cognitive processes.
Astronauts speak of a certain muddiness of cognitive thinking processes during the first few days of spaceflight. It seems that for the first few days after we arrived, that we're just not quite as sharp as we were on the ground. While neurological and thinking or cognitive processes can be studied by measuring signals from the brain and from the peripheral nervous system. That's the reason why we wear this amusing hat. Within the hat, there are 54 electrodes that monitor our brain waves, or EEG signals. It also contains electrodes that monitor eye movements. Elsewhere on our body, we wear sensors that monitor muscle movement in our hands and also our cardiac rhythm as well.
You ever notice how astronauts look all puffy in the face when they first go into orbit? Well, let's check in with Bob again to find out why.
On Earth, our heart pumps oxygen-rich blood up to the brain. And then, Earth's gravity helps pull the blood back down to the lower parts of the body. Since the brain is the capstone of our proverbial pyramid, our heart has to work especially hard to pump blood up to it. But in weightlessness, there is a difference. The blood volume in our head and chest increases. For those of you who know me, you recognize that my face is now rounder and puffier than typical on Earth. Anyways, this increased central blood volume in space reduces the workload of the heart. This doesn't pose a challenge to our health while in space, but it can have negative consequences once we're back on the ground.
Basically, the heart doesn't have to do as much work to pump blood when on orbit. You might say it gets lazy.
To understand just how that happens, we have to know a little bit about blood flow. Cardiac output is the amount of blood in milliliters pumped by the heart in 1 minute. On Earth and in space, different conditions can change cardiac output. To find cardiac output, we use multiplication. Cardiac output, or milliliters of blood per minute, equals stroke volume in milliliters per beat times heart rate, beats per minute. On Earth, stroke volume is about 75 milliliters per beat. An average adult's pulse rate is about 70 beats per minute. If we multiply 75 milliliters per beat times 70 beats per minute, we find that an average cardiac output would be around 5,250 milliliters per minute. We know that 1,000 milliliters make up a liter, so about 5.25 liters of blood are pushed through the heart each minute. We also know that the human body holds about 5 liters of blood. That means that in a minute's time, all of the blood in the body is pumped through the heart.
But what about cardiac output in space?
The pooling of fluid in the upper part of the body, that puffy head stuff Bob Thirsk was talking about, signals the heart to push more blood through the heart with each beat. As a result, the astronaut's stroke volume is increased to about 90 milliliters per beat. But something else happens in microgravity when the body senses the extra blood in the upper body. It interprets the pooling blood as too much fluid, something called overhydration. This signals the kidneys to remove the water from the blood and get rid of it as urine. After only 1 day beyond Earth's gravity, astronauts have a lower blood volume. They can lose as much as 20% of their blood volume while on a space mission. Since the body has less blood to push around and the heart is pushing more blood with each beat, an astronaut's heart rate also slows down to compensate. Astronauts just don't need as much blood in the environment of space, and the heart just doesn't work as hard to move the blood through the body. So an astronaut's heart rate and blood pressure are carefully monitored before, during, and after missions, and astronauts take special countermeasures, like exercising and drinking lots of fluids just before returning to Earth, to help their bodies return to normal. So the next time you take your pulse, think about the doctors, nurses, and medical technicians who are monitoring the astronauts, keeping them healthy in space. I'll see you next time on Real World.